Prove that the midpoints of the sides of a quadrilateral join to form a parallelogram. This is quite a tricky one. So let's just draw sort of any old quadrilateral. So something like this. Let's say that's O, A, B, C. And I'm going to define a vector. See, I'm going to call it 2A along there. I'm going to define a vector that goes across the middle here, and I'm going to call that 2B. I'm going to call this one 2C, and we're interested in midpoints. So we're going to have these points here. I'm going to call them P, Q, R, and S. Now, what we're trying to show is that these midpoints, when they join up, those form a parallelogram. So we're going to be interested in PQ and comparing it to SR, and PS and comparing it to QR. So OP I can see is just A. Remember that P is the midpoint. So let's think about how we go from O to Q. Well, to start with, I'm going to think about going from A to B. So that's going to be BO. No, it's going to be AO and OB. So that's going to be 2B minus 2A. Therefore, AQ would be equal to B minus A. And therefore, OQ would be 2A plus the B minus A. And that's going to be A plus B. Now that one's an important result, so let's double underline that, and that one there is an important result as well. In fact, let's underline those important results. Let's underline them green. These are the ones we're going to really want. Alright, we'll do the same sort of thing over here with S and R. So OS, that's clearly going to be just C, and that's an important result, so let's underline that in green. And what else do we want? We want OR. So let's think first of all about CB. So backwards along here, so that's minus 2C. And then we'd go 2B. So CR is going to be half of that, so that's going to be B minus C. And then going O to R, we'd go here first, so 2C, and then we'd add on to that CR. And so that one is going to be C plus B. Let's underline that. So those four results are really important, and we can move forward from those. So let's think about PQ. So I could go P to O and then O to Q. OP is A, so PO is minus A, and then OQ, we need to add A plus B, so that's just going to be B. So that's PQ. Let's think about SR. So SR would be going from S to O and then from O to R. Well, SO would be minus C, and then we're going to add C plus B. So that one is just B. And from there, we can see PQ is equal to SR, which is what we'd expect in a parallelogram. And then we've got to do the other ones. So we've got PS, so that's going to be PO plus OS. So PO is minus A, OS is C, so that one's going to be C minus A. And then we also want, so that's PS, we want QR. So QR would be QO plus OR. So QO, this is OQ, would be minus A minus B, and OR would be C plus B, and the B's cancel there. I end up with C minus A. So at that point, we can see that PS is equal to QR. And so we have opposite sides which are equal in length. So PQ being equal to SR completely is equal in length and equal in direction. So that's PQ and SR. And then PS and QR, those are equal to each other and parallel. So that's those, and therefore we have a parallelogram.